Hello everyone, this is Evangeline Supriya working as an associate professor in the Department of H&S, SRIT Engineering College, Rotripuram, Anantapur. Welcome to the Engineering Physics Lab. Today we are going to perform the experiment BH curve. So the aim of the experiment is to determine the energy loss by tracing the hysteresis curve by using a transformer core using CRO. First of all, what do you mean by hysteresis curve? The lagging of B behind H is nothing but hysteresis curve, where B is the magnetic flux density, H is the magnetizing force. As you can see, the principle involved in the BH curve is magnetic induction. So before going to start the experiment, let us come discuss about the apparatus which are involved to perform this experiment. This is called the CRO, cathode ray oscillator, and this is the entire kit to produce the BH curve. These are called the transformer core, which is a soft material, soft magnetic material and ferromagnetic material, and these are the some connections. Now coming to the experiment. So first of all, what do you mean by magnet? A material which is having the attracting property is nothing but magnet. What do you mean by magnetism? The property of a magnet is nothing but magnetism. Based on the alignment of dipole moments, there are 5 types of magnetic materials. One is dia, para, ferro, antiferro, ferri. So out of which we have chosen the ferromagnetic material. Why we have chosen the ferromagnetic material? Because the principle involved in ferromagnetic material is spontaneous magnetization. What do you mean by spontaneous magnetization? Even in the absence of magnetic field, the material exhibits magnetic properties. That is the reason from all the materials we have chosen the ferromagnetic material, which is a transformer core. So after connecting all the things, we have the circuit diagram here over here, which is a as you can see in the figure 1, we have, as you can see. Now the formula here is energy loss EL is equals to N1 by N2 into R by R1 into CL by AL into SV into SH into area of the loop. N1 is the number of turns of primary coil in the transformer core. N2 is the number of turns of secondary coil in the transformer core. R is the constant resistance. As you can see this, we have R is equals to 1 kilo ohm, and R1, R2 are the variable resistors, out of which we have chosen R1 as a variable resistors, which is 5 ohms, and this is the capacitance. We can see 4.7 in microfarad, and this is the capital L, length of the specimen 32.24, and A is the area of the cross section 2.54 centimeter square. As you can see this SV and SH, SV means vertical component, SH means horizontal component. For the CRO, we have two channels. One is the Y channel and one is X channel. Channel 2 is connected to X plate, that is X channel, that is Y channel is connected to the Y plate. Y channel represents, as you can see this, when I am moving this knob, there is a change in the horizontal position. When I am moving this knob, there is a change in the horizontal position, and this is a vertical position. So for the vertical position, we have the SV is equals to, we can see the value is 2 volts per division, and for the horizontal position, you can see the value is 0.5. So after knowing all the things, we have only one thing we don't know is area of the loop. Now in order to find out the area of the loop, we have to take the trace paper and trace out the hysteresis curve on the trace paper, and we have to draw the curve like this. We have to trace out. Now after tracing out, we have to find the area of the loop for this hysteresis curve. Now to find out the area of the loop, as you can see this, the value of this one in the graph sheet is 100, out of which we have in this box 100 pixels, 25, 25, 25, 25. Likewise, you have to count the number of pixels for each pixel value is 10, so that we can get the area of the loop from this graph. Now we have to Substitute this area of the loop value in the BH curve formula. You can see EL is equals to N1 by N2 into R by R1 into CL by AL into SV into SH into area of the loop. After doing the calculations, we will get the value energy loss. Now, we got the energy loss by tracing the hysteresis curve, the BH curve. The only thing you should remember in this BH curve is the lagging of B behind H. So for that, we have taken the transformer core, which is a ferromagnetic material, which is a soft magnetic material. That is why we got the narrow hysteresis curve, because it is a soft magnetic material. So this is the overview of the BH curve. Thank you.